The biggest thing that has happened for the Ethereum ecosystem so far, right, this year, right, is this very important milestone that we had back in March, right, which is EIP 4844, right? So EIP 4844, the big thing that it introduced is it brought blobs into the into Ethereum, right? So what are blobs? Blobs are this extra piece of data that you can put into Ethereum blocks where this data cannot be accessed from the EVM, but the blockchain still guarantees that the data actually was published and that the data actually is there. And so that data can be used by layer 2 protocols for scaling, right? So the capacity of any rollup is basically determined by the capacity of the blobs. And we have, in 4844 actually introduced this extra storage for the first time. And so as a result, it basically created a separate fee market for layer 1 execution and for layer 2 call data. And as a result, transaction fees for layer 2s have gone down from being about 10 to 50 cents to being like base under 1 cent, right? So very close to zero. So this is big, right? This is very important. And the reason why this is important is that like the difference between blockchains costing $5 per transaction and 20 cents per transaction and 1 cent per transaction is basically the difference between life and death for pretty much everything except for like high value DeFi and like paying $3 million for a picture of a monkey, right? If you're paying $3 million for a picture of a monkey, you don't really care if your transaction fee is like 1 cent or a dollar or even $5,000. If you're just trying to create an application for like regular families to hold money on chain, to make transactions, to do international payments, if you're trying to put games on chain, if you're trying to do DAOs, if you're trying to do like anything else, then the chain needs to be affordable, right? If it's not affordable, then it can't be the next wave of the internet. So this year, just for the last 6 months, layer 2s finally are affordable, right? And so this is a really big shift. And I mean, I think already, right, we've been seeing a pretty huge growth in usage as a result, right? I think we're up to the total layer 2 ecosystem is somewhere around like between 200 and 300 TPS right now, and that number is only continuing to grow. So Ethereum is scaling, right? This is something that we've wanted to do for a long time, but it's actually finally happening. So the question that I think is important to ask is basically, where do we go from here, right? So it's clear that we've actually made a lot of progress. It's clear that scaling actually is happening. We've also this year seen both Optimism and Arbitrum as the first rollups to actually reach stage 1. And so we're seeing a lot of good progress and milestones in terms of security and decentralization, which is also really good progress. And so all of these things are improving, right? And so the question is, well, what is left to be done, right? What do the next 5 years of Ethereum's scaling as a layer 2 ecosystem actually look like? So part 1, right? So the future of data availability. So today, blobs are incredibly cheap. But if more people start using blobs, then of course the gas market is going to go up and blobs are going to become more expensive. So if you look at the data availability that we have today, right? We have 384 kilobytes per slot in EIP 4844. I think it's like actually maybe somewhere around like 375 to 378 kilobytes because these aren't chunks of 32 bytes. They're like 253-bit field elements, but like same thing. 384 is a round number. Take 384 kilobytes divided by 12, you have 32,000 bytes per slot. And then if you are just dumping transactions on chain uncompressed, then you divide by around 180 and you get like maybe something like 200 TPS, right? And so we're basically above that already. And part of the reason why is because some of Ethereum's layer 2s are not rollups, they are either Validiums or things with other kinds of security models. So right now, we're at a level that is fairly low, right? But there is a roadmap to push both of these numbers up quite significantly. So one part of this is, so if you look at this, right, basically it's a fraction. And you can ignore the 12 because that's the block time. Like realistically, even if we figure out a way to make the block time 1 second, to keep bandwidth tolerable, we'll have to divide the number of bytes by 12 as well. So you can think of it as, the numerator is the bytes per second, and the denominator is how many bytes in a transaction. So the first part is how to actually make data availability on Ethereum have more space, right? So here, the whole reason why we did this whole data availability blob concept is so that we can move away from this idea where every Ethereum node is verifying every single blob, and we can instead use this like probabilistic approach, right? Data availability sampling basically says every node only randomly downloads some portion of the data, and by doing that, you verify that the whole thing is actually available. And then for long-term storage, over time, we can also build a peer-to-peer network to like actually store blobs in a way that is like super backed up and super reliable. I actually think in a few years, I expect blob storage to be more robust than Ethereum history storage is now, right? And the basic math behind that, right, is that if you have 10,000 nodes, each of which store 100% of the data, that's actually not a single bit better. Like that's than 1 million nodes, each of which only store 1% of the data, right? And so we need, in order to scale, we need to get away from everyone storing everything. But if we want the same level of assurance, then we just compensate and we say each node stores some portion of things, and we try to have more nodes. So PeerDAS basically is the first version of data availability sampling, which says that to verify the data, every node only downloads a random small portion of it. And then you have erasure coding so that if most of a block is available, then like that lets you recover the rest of the block. So PeerDAS is the first version of that. It can get you to 1 to 4 megabytes per slot. And then full DAS goes even further, and you can get to 16 megabytes per slot. At least this is like the target. But potentially you can go even further from here. So that's the numerator. We can also talk about the denominator, right? So this is roll-up data compression. So today, this is one of those things where we still haven't really moved forward by much, right? So some roll-ups are just dumping uncompressed transactions on chain. Uncompressed transactions about 180 bytes. This is for an ERC20 transfer. If you compress 0 bytes, so if you basically replace every long sequence of 0 bytes with 2 bytes that say, like basically 1 byte is the flag and then the other byte is how many zeros there are, then you can knock transactions down to about 154 bytes. But there's a lot more compression that you can do from there, right? So if you switch to ERC-4337 and you use ERC-4337 with BLS aggregation, then you can take an unlimited number of signatures, you can aggregate them together, you can verify the aggregated signature. It takes about the same amount of computation, but the amount of data, instead of being like 64 times n for n operations, just becomes 64 bytes for as many operations as you want. And so if you do that, then it goes down to about 128 bytes. Then if you figure out how to make like really ideal stateless compression, so this could even include things like, for example, if you think about transaction values, then you can actually store them in scientific notation, right? Like basically, the average amount that gets transferred, it's like 2 or 3 decimal digits, right? It's like I'm sending you 0.5 ETH, you're paying your gas fee in like 15.7 Gwei, like it never goes above like 3 significant digits, right? And so you can basically come up with like a custom version of decimal floating point, and you can cover like basically almost everyone's transaction values and gas price. Then you can figure out more things like if there's a field that contains an address, you don't need to store how many 0 bytes there are because you know that there's an address there, and address has 20 bytes, right? And so if you do that kind of ideal compression, you really figure things out, the math says you can go down to 75 bytes. If you do stateful compression, so stateful compression basically says if you send a transaction that contains an address, and that address has already been handled by the chain before, then instead of including the address, you include a pointer to the location in history that contains that address before, and so you can replace 20 bytes with 5 bytes, and so you can go all the way down to 23 bytes. So on the left side is like Ethereum L1 responsibility, on the right side L2 responsibility. So you guys, yes, you can go and make Ethereum L2s like about 7 times more scalable. If we do all of this, then with rollups, the math says you can get to about 58,000 transactions per second of ERC transfers. So who here wants to do 58,000 TPS of ERC20 transfers? Who here wants to do more than 58,000 TPS? I'll talk about that too. So let's talk about Plasma. So who here remembers Plasma back from like 2017 or 2018? So Plasma is this really fascinating scaling technology, right? Which basically says that what we do is you have a Plasma chain operator. The Plasma chain operator creates a block, and they publish a Merkle root of the block on chain, but the actual block stays off chain. And the block has this like special rules, right? The special rule basically says that if like Plasma, the base layer, it works with like NFTs, right? Like discrete coins. And if you want to use it to deal with like ERC20 tokens, you basically just like turn every unit of the ERC20 into an NFT, right? And so for every NFT, the NFT gets assigned a position. And in order to, like any transaction transferring that NFT has to be included in the corresponding position. What does this mean? It means that if you as a user have a particular NFT, you only need to track the portion of the history that corresponds to that particular position. You only need like one branch per block. And then the other part is that when you want to withdraw, there's basically this exit game mechanism where in order to withdraw, you publish the latest Merkle branch, and then if there is some kind of fraud, if let's say you're exiting a coin that you already spent, or you're the Plasma operator and you did something invalid, then other people can challenge you, and then there's like a fairly simple challenge game. It's a really cool mechanism. It's kind of fallen out of favor, basically because back in 2018, it did not seem practical to generalize, right? It's like it works well for payments, but it's extremely hard to figure out how to generalize it even a little bit. Like even figuring out an efficient generalization to go from NFTs to coins and like solving the defragmentation problem, like even that was friggin' hard. So that was then. Today we have Snarks, and I think the entire world has basically moved on to being like Snark and Stark default, right? Snarks make Plasma much more viable even for complex use cases because Snarks replace fraud proofs and they're conceptually much, much simpler. And so with Snarks, you could actually take Plasma, you could give it much more powerful properties. For example, if you have a Plasma system, and let's say it's just a simple one that's for transferring NFTs, in the normal case, so in the case where the operator is honest, as a user, you can withdraw instantly. No waiting period. The reason is that you just basically withdraw a coin using the latest tree. And if you withdraw a coin using the latest tree, then there's nothing that can possibly come after that that can say that you've already spent the coin, and you know that you're withdrawing something valid because the Snarks prove that every tree is valid. Now, one important insight, I think, is that like a lot of people think about there being, right now, if you're a ZK VM, you have validiums and you have rollups. Actually, yeah, I think validium to Plasma is a spectrum. And you can take any existing Validium and you can add even a little bit of Plasma technology in order to make it safer, right? Because you don't have to cover every coin. You can make a design where, for example, only coins that have not been touched for 1 week are unconditionally safe, right? So if you have coins and you have not touched them for 1 week, then even if the Validium operator publishes a block with unavailable data and then disappear, even in that situation, you're completely fine and you can withdraw. And then you can start like walking up the spectrum and basically start to see like what other kinds of safety you can add. And it turns out that you can actually add quite a lot of safety for an EVM Plasma system. So Plasma, off-chain data, so Plasma can go even higher than 58,000 TPS. Plasma designs do have weaknesses. For example, they depend on centralized operators. Now, there are also interesting hybrid plasma rollup designs. So IntMax, for example, is a hybrid plasma rollup. It puts 5 bytes on chain for every transaction. And so if you go back to the math over here, then basically, 16 million divided by 12 divided by 5, and you can do, and that lets you do a theoretical maximum of 267,000 TPS, right? So, and then we can go much higher. And what do you get for that? Well, you get plasma properties, plus you get even stronger properties in the case of dishonest operators, plus you get privacy. So a lot of really amazing stuff in the plasma space as well. You have to think harder to build a plasma, but you can. Pre-confirmations, right? So pre-confirmations basically let layer 2s have faster with confirmation times than layer 1. And the way that I see the space is basically that there's like these a spectrum of 3 possibilities, right? One is centralized pre-confirmations, where you basically say, yo dog, I'm a server, I'm proud of it, I'm going to give you 40 millisecond latency, but at the same time, you get security and you get censorship resistance because ultimately the thing is committing to layer 1, and so you're prevented from cheating, and there's like some kind of forced inclusion channel, and so even if you're being censored, you can try to push things through on a layer 1. So option 1 is centralized pre-confirmations. If you want to be a little bit more decentralized than that, then you can have like some mini committee doing decentralized pre-confirmations. And then option 3 is you give up on pre-confirmations unless you decide to do them, through the L1 sequencer market or whatever, and you make a based rollup. So this is sort of the spectrum that I see right now, right? And right now we see, realistically, there's like a bunch of rollups with centralized sequencers. Tycho is a based rollup, so it's amazing that we actually have those. And I expect, we're going to start seeing movements toward decentralized sequencing over time. My opinion is that like the top priority is really getting to stage 1, right? Because if you're not stage 1, you're basically just a multisig. And if your rollup is just a multisig, then like you're not a real rollup. And I think it's 2024. The ecosystem has to get serious. If in order to be a rollup, or even be a layer 2, you have to have actual security. If you don't count. So I think, but going a little bit further beyond that, and in decentralized sequencing, either through a committee mechanism or through being based, is one of those things that it would be really nice to see more movements toward, and I think we're starting to see some movements toward. So stage 1, we have Optimism and Arbitrum, and a couple of ZK rollups have told me that they plan to be stage 1 before the end of the year, which will be exciting. Now, the other big part of this is like, how do we get from stage 1 to stage 2, right? So stage 1 says you're allowed to have a security council that can override the proof system, but it has to be a 75% threshold, and at least 26% of the members have to be outside of the organization that runs the rollup, right? So your company by itself no longer actually even has the ability to override and make the output be whatever it wants. Stage 2 says, well, actually the rollup is protected by the code, and the only case in which a security council is allowed to run is a case in which the code provably disagrees with itself, right? So for example, you could have 2 different proof systems that give different answers, or you could have one proof system that accepts 2 conflicting answers for the same block, or you could have a proof system in the other direction that like accepts nothing for 7 days, right? Stage 2 says security councils are only allowed to interfere when the code like breaks in a way that's provably broken. There's 2 ways to do it. So one of them is multi-provers. Multi-provers basically says you have multiple proof systems that are written in different ways, and guardians can only intervene when they disagree with each other. And the only thing that the security council can do is they can say either one proof system is right or the other proof system is right. They can't just like come in and take the money for themselves. Also, formal verification, so using some advanced techniques to try to like actually computationally verify that a ZK EVM implementation actually accepts only blocks that actually pass the underlying EVM specification. And also, along with this, another important trend is EVM proving becoming faster and faster. So a couple years ago, an Ethereum block took about 5 hours to prove. Then it became 20 minutes. Now I know of at least one project that's able to prove at least average Ethereum blocks in 15 seconds. Now they do have to have lots and lots of GPUs in parallel, but they can prove average Ethereum blocks in 15 seconds. And I think we have to get to the point where we can prove worst case Ethereum blocks within 4 seconds. I think we'll get there. Layer 1 versus Layer 2. So this is an important discussion, right? It's like, which use cases should be on Layer 1, which use cases should be on Layer 2. So use cases that definitely should be on Layer 1. Obviously, L2-related transactions cross L2 movement, but then there's, I think, arguments that certain other types of activity make sense to do on Layer 1. So high-value DeFi currently happens on Layer 1, and Layer 1 is the Schelling point, and like that, like arguably makes sense to something to continue to build and design for. Also, account key stores. So if you have a wallet where you want to be able to adjust the wallet's configuration once, and then have that immediately apply across all the Layer 2s, the approach that makes the most sense is you put the configuration on Layer 1, and then you have Layer 2s that are able to automatically read the Layer 1. So you have, there's the L1 SLOD opcode, there's the EXT static call opcode, a couple of ways to do this. So what kinds of levers do we have to try to influence this, right? So one is Layer 1 trying to scale more. And so one natural approach is to try to make certain specific operations much cheaper. So for example, really trying to optimize for cryptographic proof verification. If you do that, then that's actually good for Layer 1 applications, especially privacy things. And at the same time, it's also good for Layer 2s because it makes Layer 2 proofs cheaper, which helps keep Layer 2s more decentralized. Another interesting lever, this is like one of those moon math research topics, can Layer 1 safely decrease its block time? Unknown, open question. Maybe there's a way to have a safe, highly decentralized system that has 4-second finality or at least 4-second blocks. And then if you do that, then maybe Layer 2s will not need decentralized pre-confirmations. Basically, everyone will just either be based or be a server. Or potentially, yeah, it might just make sense for safety for Layer 1 to be slower. In that case, there's more room for like different intermediate confirmation tiers. Infrastructure updating for Layer 2. So one big topic is chain-specific addresses. So basically, the address should include which Layer 2 you're on. So the address should include not the 20-byte account ID, and it should also include which chain you're on, right? An address should fully include like what is the actual location that you're asking to receive money at. And so one alternative is the ERC 3770 approach, which is already used in Safe. Another proposed alternative that's been gaining traction recently is like this idea of basically taking the registry of Layer 2s, and instead of having an off-chain centralized one, you actually just use ENS for that. Light clients. So light clients are starting to happen for Layer 1. We have Helios. Helios is getting better and better. We need those kinds of safety guarantees to also apply to Layer 2s. We need Ethereum to be a maximally trustless ecosystem. This should apply not just to Layer 1, also to Layer 2s. And so standardizing light clients, standardizing how you do state proof verification, really valuable. Cross-chain transfers, gas payments, there's a couple of ERCs for this. So I think there's been a lot of discussion recently, right, about how Layer 2 has different kinds of fragmentation, and I think this is a problem that we can tackle head-on and we can solve. But in order to do that, I think we need to start with some things, and I think what we need to start with are low-hanging fruit that doesn't even require extremely fancy math. It just requires like basically doing some pretty basic UI stuff to make the ecosystem at least feel much more unified than it is today. And I think we've made some progress on that already, right? Like 2 years ago, you had to manually switch networks in your wallet. These days, I haven't done that for about a year, right? So I think if we keep moving forward on cross-chain addresses, making cross-chain sends an automatic feature, built-in feature of wallets, doing light clients, then we can actually get pretty far. So conclusions, right? Layer 2 technology is continuing to improve. I think there is an interesting open question of like how much Layer 1 does, right? There's opportunities for Layer 1 to do more in order to benefit both applications that are directly on Layer 1 and also to provide valuable services to Layer 2s. For example, if an L1 adds a very strong inclusion list feature, which adds this like very strong guarantee of protocol level censorship resistance, where it's hard for centralized builders to block a transaction even for 1 or 2 slots, then that's something that based rollups would benefit from automatically, right? And how much layer 1 does also affects what ideal layer 2 designs work. And also, there's one of the big things that we need to really work on more is building standards and infrastructure, and we want to make sure that the usability and the security properties that we've known and loved on and wanted on layer 1 from the beginning are properties that apply on layer 2 as well, right? So you should be able to make a payment from one layer 2 to another layer 2, and it should feel the same way as making a payment from Ethereum to Ethereum. You should be able to verify, have a full chain of trust verifying the state of any particular object on layer 2, and it should be as trustless as verifying layer 1. These are all things where there's a lot of work that needs to be done, but to me, these are really the next steps that we have to go through. And I think if we keep going, then the layer 2 ecosystem can continue to be even more of a success. Okay.
Can we keep Vitalik on the stage with us? Okay. So here we'll have a Q&A session with Vitalik for 10 minutes. And then, so people in the audience, raise your hand if you have any question for Vitalik. And don't sell yourself or your own project, okay? It has to be a question, a real question. Okay, guy over here.
Yeah.
Thank you so much. So you mentioned layer 2 specific addresses. So for example, we have an Optimism specific address, right? What would happen if you were to send ETH mainnet to this address? Would it just disappear, or does it have a real ERC20 address too?
Right. So the idea is that from a UI perspective, you would not be able to, right? Because basically what you would do is I would give you an address that says 0x blah 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 add optimism.eth. I would give it to you, and then you would put it into the to field of your wallet, and then your wallet would then just automatically interpret that as a request to send this number of coins to Optimism, and it would just automatically process that as a cross layer 2 send instead of an Optimism, an Ethereum to Ethereum send.
So basically, you'd be able to access it just because you have access to the main wallet, essentially, right?
Right. Yeah. It's basically it would be the wallet's the wallet would know, the wallet knows which layer 1 or layer 2 you have assets on, and from the address, the wallet knows which layer 1 or layer 2 you want to send assets to, and the wallet would be able to route the request.
Okay. Yeah, makes sense. And one more quick thing for. At the layer 1 side, you mentioned that earlier with the space of 16 megabytes. At what point in the future do you think we're going to get there?
Yeah, so I think, best case scenario with PeerDAS is that we get PeerDAS in either Pectra and if not immediately in Pectra, then sometime early next year. And with PeerDAS, you can get to 1 to 4 megabytes, which is already a pretty significant gain. And then I think from there, it just should be an incremental movement toward the 16 megabyte level, right? Basically, you just keep on waiting for the technology to mature, keep on increasing the parameters over time, keep watching the network carefully, and I think we can get there over the course of a couple of years, and then we can keep going.
Okay, next question, guy over here in the front row.
Yeah, Vitalik, привет.
Привет.
And my first question, what's better, optimistic rollup or ZK rollup? What do you think? First question.
Yeah,
and second question.
I think in 10 years, I expect all rollups will be ZK rollups that commit to Ethereum every slot. So that basically means that everyone, including the optimistic and the existing ZKs, are going to have to pretty massively change their tech stack and the way that their proof system works.
And second question, what will happen with Ethereum? I mean about price, if layer Okay, it's my question. Sorry.
The
I'm from Russia. I want to know.
The price of ETH will be 400,000. I won't tell you what currency.
I mean, like, if. Okay. I'm bullish on Ethereum, you know? I'm bullish. And if layer 2 decision improve and станут масштабируемыми, can Ethereum price will be more than 10,000? What do you think?
That's up to you. It depends on how much ETH all you guys buy.
Yeah, we're all here today because we're Ethereum massive, right? We didn't go to breakpoint.
Yes.
Okay, next one. Raise your hands. Okay, girl in the back. White Q, girl in the back in white.
Hi, hello. My question is about what is the specific solution for cross layer 2 interoperability problem?
Yeah, I think different people mean different things by interoperability, right? So the way that I think about this is you want to start from the basics, right? And the basics are one of the things that I sometimes I retweeted a couple of months ago and that I put into half of my presentations here is this screenshot of Polymarket's deposit interface, right? And I love Polymarket, and I think it's an amazing news service because that's basically what it is. But that deposit interface is total basically what it says is here is your address, and then you figure out how to deposit USDC on Polygon to that address. Make sure to deposit on Polygon, not Polygon ZK EVM. Those are different. If you deposit to the wrong one, you lose your money, right? It's almost imagine if JP Morgan and Morgan Stanley were different banks, right? So it's the whole thing is just confusing, right? And I even actually lost $100 to it myself, right? And so basically, yeah, what the way that should look is that should look feel in a way that's natural, right? In that particular case, if it instead had a chain specific address, then you'd be able to just copy the address, put it in your wallet, and then deposit. But then the ideal thing is it would just have a deposit button that you can click, and then you would have a Web3 API extension that just automatically asks your wallet to do a cross layer 2 route to whatever the Polygon address is, right? So to me, the first step is both the UI side of that and also the side of having a cross layer 2 a coin transferring protocol that just is completely decentralized, that is maximally robust, that does not rely on governance or trust assumptions, and that's guaranteed to keep existing in 5 or 10 years, right? And I think ERC 7683 can be that, because if you think about the properties, right, all you have to do as a user to make a trade is you only have to, on the chain that you're sending from, make a transaction where you send your coins to a smart contract. Everything else gets done by liquidity providers, right? So there's no IP addresses to talk to. There's no trusted actors to know about. There's basically no trusted actors. There's you don't even need Waku or anything, right? It's just purely on chain. And so that's just sending money, right? Then if you want more the second step is, I think, all layer 2s should be able to synchronously read layer 1. So L1 SLOAD and EXT static call are the two options for that. And if you do that, then you can have key store wallets, you can have all these other solutions. And that's layer 2, and then or step 2. And then step 3 is start exploring synchronous composability and start making it easier for high value transactions that are on layer 2 to pop into layer 1 if they need the liquidity. But I think things like that can also happen later. So basically, just start with the basics, and as you figure out the basics, keep improving from there.
Okay, we have room for one more question. Maybe Vitalik, you pick your.
Okay, let's back in the room. The black pouch person, yeah. Okay.
YQ is doing some sports today. He always complains to me he's getting fat for overworking too much.
Thank you. First, I'm your fans.
Wait, I said the black pouch person.
Okay. Oh, dang.
Oh no, sorry.
Thank you.
Okay.
I have two questions. So, first question, who from your perspective is the biggest competitor to Ethereum? And
The centralized world.
And the second question, what do you think you need to improve from a business perspective to stay in a competitive edge?
I mean, I think the big thing is just like transaction fees and user experience need to be competitive, right? Like I remember, even in countries where you have all of these amazing statistics about how like 11% of the population owns crypto, often the way that usually works is they do like internal transfers inside of centralized exchanges, right? Why? Because they're free and instant. And so I think the decentralized world, like the Ethereum world, needs to have transaction fees, user experience in terms of convenience, and user experience in terms of security that's competitive enough that it can beat that. 1-0. Okay. Okay, fine. I'll let you ask too. Last one. Yes. Okay. One sentence question, 2 sentence answer. We'll make it fast.
First, I'm a simple question. I want ETH to use my life.
You want ETH?
What's the time? How about the time I use more in country, not in for country, for that's my life. I'm living in Hong Kong. I live in China. I live in Singapore. So I want to use the ETH more. My question is it. All right.
When you'll use ETH more in your life?
He wants to use
wants to,
ETH more
yeah.
in his life, which is like payment rail and stuff.
Of course, yeah. I think. I think that there is a good opportunity to start it being used much more widely for, like, especially international transactions, right? Like, I use it for charity donations all the time. I use it for like lots of international payments. I think we definitely want to get more services actively accepting it, right? So we want to see more of these. There's a lot of like consumer merchant like payments infrastructure that needs to be improved. There's basically you need, I think, 10 more equivalents of like companies in Coinbase, companies like Coinbase that specialize in different regions and different industries. And then once you have that, then like you will have like ETH as a payment option be available everywhere. And then like those companies need to be both good at being on ramps and off ramps, and they need to incorporate all of this like layer 2 stuff that we already talked about. So I think that's like one side of things. And then the other side of things is like microtransactions in the context of different applications, right? So like if, for example, like Farcaster continues to take off, then like I expect you're going to see some form of Ethereum based like payments features get incorporated into it. So I think like any kind of decentralized social thing taking off also creates, it uses the blockchain, and I think it also creates an opportunity for a lot of like the cryptocurrency features to naturally add on top of that as well. So I think like there is a big opportunity, but it's also something that we have to work for.
I want to add that you need to make it happen. You need to make Ethereum accepted in more locations and more shops, so more people can use it. Okay, we'll call it a wrap. Given the time concern, we're very honored to have Vitalik here again. Let's give him another round of applause.